Hey class, it's Mr. Chang. We got to talk about 7.4, present value of an ordinary simple annuity. This is going to be our last lesson on annuities and actually our last lesson for the year. Okay, next week I'm going to put up some videos for you to just watch. They're like Princess or For Richer or For Poor. It's just about people making having to make financial choices with their budgeting and trying to get out of debt. Till death do us part. I think that was another one. So we'll see what I can get and put up for you guys to just browse around and watch. Okay. But our last lesson is 7.4, present value of an ordinary simple annuity. The goal here is to calculate the amount of money required to in an account to finance a regular series or a series of regular withdrawals. Okay, so it is different from that future value concept with the payments here, because the context here typically has to do with, how much money do I have to have in the bank account now so I can take out, a certain amount every 2 weeks or every month for the next 5 years or the next, 10 years. You want to be able to coast on an amount of money. It's kind of like if you had $100 and you had to survive off of it for the next, 8 weeks, right? Well, then most people would just take the 100 and divide it by 8 and see that they get $12.50 every week to try to spend, which isn't very much really. But you can make it last for 8 weeks if you do that. Okay, if you don't budget it, you could actually just blow off the $100 on your first day and have nothing to live off of or do anything with for eight weeks, which isn't a great idea either. The only difference is, what if instead of taking $100 and dividing it by 8, because it's $100 is sitting on your counter at home, but what if you put the $100 in a savings account so it could earn money, and as it earned money, it's growing in compound interest, but you're taking out chunks, okay, for 8 times until it turns into 0. This way, you can either take out more money, or, because it's growing, right, or you can make it last longer, maybe for 9 weeks, which would be pretty cool. Well, we're going to play around with that idea, okay? Or you can put in less money, like $90, and make it last for 8 weeks and get $12.50 every week, just because it's growing as well. So that's the concept. Here is our formula. Oops. Let's get that going. I thought I clicked the highlighter, but obviously I didn't. Here we go. PV is equal to payment times 1 minus 1 plus I to the exponent negative n, all divided by I. Okay? We already talked about what payment is. It's your regular withdrawals that you're going to do for n periods. And the account earns an interest rate of I per period, which means we take the rate and we divide it by the amount of periods that happen a year, or compounds per year. Okay, so examples. The first one here says you have an investment account that pays 5% compounded quarterly. You wish to withdraw $200 every 3 months for 4 years. How much would you need, or how much do you need to invest initially or today to finance the annuity? Okay, how much do you need to invest today or initially? Initial means at the start. You should be thinking, oh, we're not talking about future value. It's not how much will you have, it's how much do you need right now, right? So that is a present value question. Okay, this indicates present value right here. And it's asking you for the present value. So everything else should be parts that you would fill in on the right side of the present value equation. So let's do that. Let's start with the formula. PV is equal to, and we're going to write PMT. In the square brackets, it's 1 minus, round bracket, 1 plus I, all to the exponent negative n, close the square bracket, all divided by I. You don't need to memorize this formula, just like the other formulas. I give you the formulas. You just need to take the information from the question and plug it in properly. Okay, what else do we have here? We got the payment. Yeah, you want to take out $200. Okay, every 3 months for 4 years. When you take it out every 3 months for 4 years, that actually indicates how many compounds you have per year. In this case, it's 4, right? Because you'd be doing it quarterly. And that's the same thing right here. It's quarterly. It's also 5%. Okay, so let's try to talk about all those details. The PMT is equal to 200. All right. The I value, we need I, right? We got PMT there, we need I, and we also need N, all right? That bottom I is the same as the top I anyway, so I is equal to R divided by compounds per year. So what is that? Well, your rate is 5%, written as 0.05, divided by your compounds per year, which we said was quarterly, so that's 4 times. We're going to take the year and split it into 4. And lastly, this would be 0.05 divided by 4, which is 0.0125. Okay, and we also got to calculate N, so I'm going to squeeze it down here. N is equal to your compounds per year times the number of years you go by. That'll give you the total amount of compounds you're going to get throughout the entire thing. So if we're going 4 compounds per year, because it's quarterly, and we're going to go for 4 years, we're going to go 4 times 4, which is 16 total compounds. Okay, so on the right side over here, you guys can go ahead and plug in all those details and work it out. Okay, be very careful. Use the negative button when you're applying negative N up there on your exponents for your calculator. Don't use the subtract button. And other than that, everything should work out pretty smoothly. Let's see if you get the same answer as me. In 3, 2, 1. All right, so did you get this? Look at what I've got here. There's the substitution, right? There's a calculation of all the different points and the substitution right here. And you can see just in the very details here that, I used the negative 16 up top, and I ended up with a present value of $2,884.06. I'm saying that you need to invest $2,884.06 in today so that you can take out $200 every 3 months for 4 years. A total of 16 times. And if we didn't have this investment that was earning money, and if I just had a whack of money and wanted to take out $200 for a total of 16 times, well, that would be 200 times 16, $3,200. I could do it. But you see, if I'm going to get an investment account where I can put in money and that money is going to grow, and at the same time I'm taking $200 out of it, well, as long as it's growing and I'm taking $200 out of it, I actually don't need to start off with $3,200. I can start off with less money. And in fact, you need to start off with $2,884.06. Nice, right? Okay, let's do one more. To provide a $1,000 scholarship for 25 years, how much needs to be invested today in an account that pays 5.5% compounded annually? Okay, so back at it, we are seeing that it's asking how much needs to be invested today. Present value, okay, in an account that pays 5.5% compounded annually, and we're trying to get a scholarship for $1,000 for the next 25 years. So let's do it. PV is equal to PMT, that's your regular withdrawals, times 1 minus bracket 1 plus I to the exponent negative N, all divided by I. Okay, so PV is equal to, let's take our time, let me get this in a different color. PV is equal to what, right? And we're going to find it and we're going to write it down and we're going to come up with a list of all these things just like we did up there. PV, PMT, excuse me. Okay, so take the time and try to figure out what PMT, I, and N are. And if you're feeling so bold, you can just go ahead and plug them in and see if you get the same answer. Okay, but I'll show you all this stuff in 3, 2, 1. Okay. After you figure out that your PMT is 1,000, you take your rate divided by your compounds per year. In this case, it's annually, so it's just 1, so it's 0.055, right? You got to divide that rate by 100, 5.5%, right? And your compounds per year is 1, but your years that you want to go for is 25 years, so you get a total of 25 for N. Plug them in, work it out, right, on your calculator, and you get 13,413.93266. Which I just rounded it to this because we're talking about dollars and cents, right? Of course. So therefore, you need to invest $13,413.93 today in order to receive $1,000 payments, $1,000 scholarships, to take out $1,000 payments once every year for 25 years. Now let's just do the math. $1,000 a year for 25 years is $25,000. But I mean, if you didn't have time to save and you're like, I got to do this right now because I don't have any time to save, well, then it will cost you $25,000. Right? But if you did have the time and you wanted to plan it out and put it into an investment where these guys can go, okay, if you put money into the investment will make money as you only take out $1,000 every year. You do it for 25 years as this is making money. We only need you to give us $13,413.93. Which is insane. That's pretty cool stuff. So that's that. That's the end of this lesson. Okay, and we just talked about finding the present value of how much you need to invest in order to get a simple, ordinary annuity or regular payments for a certain amount of time. Here's the practice questions, page 109 to 110, numbers 1 to 4, 6 to 8. I've got them uploaded as a PDF following this lesson. Go ahead and access that. The answers are there. You know what to do. Fire me any emails that you don't know or you can't solve, and I'll get back to you and show you how to do that stuff. Okay? Hope you guys are all doing really well, and take good care. Goodbye.